Hi, this is some notes on 4-2 area, and we're first going to start out with summation, and I have summation properties right here, and I'm just going to go through them very briefly. That when I'm summing up a constant, and I is going from 1 to n. So the summation of that constant simply is the product of n times c. So that means if I have something like this, I is going from 1 to 5, and my constant is c. The summation of this is simply going to be 5 times 6, which is 30, because I'm adding 5 6s in a row, and that's going to give me 30. Likewise, this one right here says if I have some type of expression, I don't know what it is, and I have a constant, I can bring that constant in the front. So let me give you an example. Let's say I have something like this. I is equal to, let's go from 1 to 5 again. And let's say I have 2 times 6. Well, I know that means I can have 5 12s and get 60, but I can write that as 2 times the summation of I equals 1 to 5 of 6. And I know that's 30, so I have 2 times 30, which gives me 60. So that's an application of that particular rule. This is simply saying that if you're adding two things inside the summation, you can break them up as the sum of two summations. I think that's pretty self-explanatory. And then I have these right here, which is the special rules that I have in class, and that's converting this summation form into explicit form. So what this is saying is if I have I equals 1 to 21. So I'm of I, and I'm adding the first 21 numbers. So I have 1 plus 2 plus 3 plus ... all the way up to 21. What is that sum? Now I could add up all 21 of them, but if I have 2200, a little bit more difficult. Explicitly means I can just substitute what this n value is and have a formula that gives me the sum of those numbers. So in this case, this would be 21 times 22 divided by 2, and I believe I get 231 if I did my math correctly. All right. And so the sum of the first 21 numbers, 1 through 21, is that. This is a summation of squares. So again, I'm going to have something like this. Let's see if I can do this. Equals 1 summation of to 21 of I squared means now I'm going to have 1 plus 4 plus 9 plus ... all the way up to 21 squared. Well, I could do this explicitly, and that means I'm going to have 21 times 22 times, then if I plug 21 into here, I get 42. I think that's 43 divided by 6. I might have picked a number too big, but we'll see if I can do it anyway. So this will be 7 times 11 times 43. So I have 77 times 43, and I guess I picked a number way too big. So it's 21, 231, 08, 30, and I, unless I made a mistake, 3,311 probably is the product of the first 21 squares. And the next one are cubes, and I'll do something a lot easier. Summation of I equals 1 to 5 of I cubed. So in this case I had 1 plus 8 plus 27 all the way up to 125, and this would be the same as 25 times 36 divided by 4, which gives me 225, I believe. Not 225. I'm pretty sure that's right. Okay, so those are some applications. And now what we're going to do is say, all right, how do we do these types of problems where I have a mixtures of n's and i's? Well, what I do is this n is what I call a quasi-constant. And you can write it out in the beginning, so it's going to look like this. 1 over n cubed times the summation of I equals 1 to n of I squared. Well, I have an explicit form for that, and that happens to be right down here. So this means I'm going to have 1 over n cubed times n times n plus 1 times 2n plus 1 all over 6. And I can simplify that. I can do some simplification there, and I have n plus 1 times 2n plus 1 over 6n squared. And that gives me 2n squared plus 3n plus 1 over 6n squared. And I'm done. And now what I'm going to do is I'm going to take the limit of that. And so since I've already done this, it's right here. I'm going to simply take the limit as n goes to infinity of 2n squared plus 3n plus 1 over 6n squared. And as n goes to infinity, either positive or negative, I'm squaring, and here's my degree. So both of these are degrees of 2, and the limit is going to be, since these degrees are the same value, the limit is going to be these leading coefficients, which is 2, 6. So the limit of that is 1/3 when I simplify. Likewise, I'm going to do this particular problem, and notice I'm going to take the limit, so I'm going to write the limit as n goes to infinity. And what I'm going to write here is I can multiply this, the 2 times the 2, and get the 4, and the n times n, and get n squared. So I have 4 over n squared times the summation of I equals 1 to n of just plain old I. Well, again, over here is that value for the summation. So now I'm going to have the limit as n goes to infinity of 4 over n squared times n plus 1 all over 2. And I can do some simplification here. That's the same as the limit as n goes to infinity of 2 times n plus 1, because I can simplify here also, over n. So I have the limit as n goes to infinity of 2n plus 2 over n. Here I have the same degree, so my limit is going to be 2. All right, my last one. And I need to do a little multiplication out here, and so I'm going to have the limit as n goes to infinity, and I'm going to have the summation of I equals 1 to n, and I'm going to have I squared minus 2I plus 1 all over n cubed. And I can break that into 3 summations that look like this, and I hope you're able to follow. I'm going to have 1 over n cubed, and my summation here is I equals 1 to n of I squared. And I'm going to have minus 2 over n cubed of the summation of I equals 1 to n of I, plus 1 over n cubed times the summation of I equals 1 to n of 1. All right. So again, I have values for each of these. The value for this one, and goes from 1 to infinity. I've got 1 over n cubed times this one, which is n, times n plus 1 times 2n plus 1 over 6, minus 2 over n cubed times n plus 1 over 2, plus 1 over n cubed. Now, since this is a constant, it's the product of those two. So it's going to be 1n. And now I'm going to simplify, and I get the limit. And I don't have a lot of room here, so I apologize for that. And I'm going to have on top 2n squared plus 3n plus 1 over 6n squared. We've done that one before. Minus, the 2's will simplify here. And this n can simplify, and I have n plus 1 over n squared. Plus, over here, I can simplify. And I'm going to have 1 over n squared. Now I'm going to take the limit of each of these. Well, here, the degrees are the same, so I'm going to get 2/6. Here, the degree is greater in the denominator than the numerator, so that limit is 0. And here, again, I got a constant on top, and the bottom gets extremely large, so that limit is 0. And 2/6 is the same as 1/3, and 1/3 is my answer. Alright, so that's the first couple pages of the notes.